Welcome to my presentation held at the third International Conference on Biobased Building Materials in June 2019 at the Queen's University in Belfast, UK. My name is Dr. Daniel Friedrich and I would like to report from material testing conducted by Compolytics, which is a research label about composite, polymer and policy analytics. The title of my presentation is Natural Fiber Reinforced Plastic Composites, Long-Term Physico-Structural Performance in Facade Application. And I would like to start by providing some basics about wood plastic composite materials used as cladding. And then I would like to expand on the study design to find out about their long-term structural and physical performance, then presenting the study findings, and then closing my presentation by a summary. So what are wood plastic composite materials about? They consist of a thermoplastic matrix made from fossil resources, in which wood fibers up to 80% are embedded. Then we need some additives for better bonding between these two components and also for improving particular properties. And then we receive such cladding profiles, which are called WPC cladding. When comparing today's WPC with conventional plastics and maybe with future green composite, we can see that wood plastic composite, they are somehow an intermediate technology combining conventional fossil-based plastics, which are non-biodegradable, with future bio-based and biodegradable green composites. They still consist of a fossil-based plastics matrix, at least some 20%, but by replacing the plastic matrix with compostable pure biopolymers, we could receive green composite, which in the future make products completely bio-based and therefore also biodegradable. So, having a closer look about the production technologies, we see that by extrusion technology we can further process the WPC compounds into such hollow or solid profiles, which are today usually applied in deckings and in facade claddings. But we can also apply injection technology, injection molding, where we can also produce some special products like these connectors, which are used in decking, but also other products for daily use meanwhile. So these are the typical applications today. Here are these solid profile deckings, also available as a hollow profile. Also these hollow core profile facade cladding. Also available are fencing profiles. They are all one directional linearly extruded profiles, but also by injection molding technology we can also receive such floor tiles meanwhile. So we wondered about the long-term structural and physical performance of such cladding profiles in practice, and we conducted a one-year outdoor weathering trial where we tested 3 different compounds supplied by 3 manufacturers. Consta is a manufacturer providing polypropylene-based profiles with pine fibers. Goya is another manufacturer and supplier in Germany with a PVC based WPC with 40% content of polymer where bamboo fibers are embedded, and Fibron is a supplier where polyethylene is used with 30% content and maple fibers up to 70%. We created these sample, all the same size but varying in the thickness only, but we kept one side original from the manufacturer, which then was a non-brushed surface from Constar, a brushed surface with the PVC matrix from Groya, and a layer where there was an co-extruded top plastics layer supplied by Fibron. The rear side was planned so that we had even conditions between these three sample types. They were installed and mounted on a test rack and exposed to the natural weathering on a roof mounted in central Germany, and they were then supposed to such an outdoor weathering trial according to the WPC base norm. Then we did some microscopic investigation about the surface change over this 1 year. We measured the water uptake, density as the physical properties, and in terms of mechanical properties we tested for impact resistance and also modulus of rupture to get more information about impacts on the engineering design. This was the weathering conditioned over 1 year, which was a change in the monthly global radiation. As can be seen in the winter month, this went down massively but had the peaks in the summer month, and also the minimal and maximal temperatures varied over the year. And also in terms of the lows and the highest temperature, we can see that we had indeed freeze-thaw cycles over the year, which occurred mainly in the winter month, and also the monthly rain varied over the year but did not make a substantial difference between winter and summer month. After 1 year we did some microscopy investigation, and we can see that indeed the surface changed very much at the sample type where we had a non-brushed surface and we had detachment of the fibers from the surface, and the surface became very much rough. With the second type, with the PVC matrix, we observed furrows and slight crackings in the surface and also fiber detachments, and the lowest change in surface quality we received with the sample with the co-extruded top layer, which protected very much the surface exposed to the natural weathering. So here we had the lowest change at all. In terms of physical behavior, we measured water uptake, and we can see from the first sample type with the PP matrix, we had a very fast soaking of water, and after 1 year we ended up by round about 17% of water uptake. We had a much lower level of about 10% water uptake after 1 year for the PVC matrix WPC. So PVC obviously protects the compound from massive water uptake, and we had the least water uptake over the first month with the co-extruded top layer sample type, but also then ending up after 1 year at about 17%, similar to the first type. So what we can see is a top layer protects pretty much the water uptake, but only for the short term, and PVC at all leads to a lower final water uptake level after 1 year. Then we also measured density, and we can see a significant decline in density after 1 year, which is pretty much to polymer chain scission and fiber detachments, which makes the mass going down after 1 year. In terms of mechanical behavior, we observed that we always received a lower impact strength for all three sample types, but the highest losses were measured for the first type with the polypropylene matrix, and the least decline we measured at the front side, the loaded front side, which was also exposed to the natural weathering for the third type with the co-extruded top layer, but as can be seen, we overall receive declines in impact strength, which is an important factor for facade application, which is exposed to also mechanical impacts. The modulus of rupture also went down. There were nearly no differences between the three samples, so all three WPC types significantly reduced their modulus of rupture after 1 year. This is also due to surface deterioration by fiber detachment and also polymer chain scission by the UV radiation, but also by water impacts which stayed in the compound, and also the decrease in density led to a significant loss in MOR. So what we can summarize from this sampling with outdoor weathering impact: WP surface degrades under natural weathering, mostly due to UV radiation leading to polymer chain scission, also leading to water uptake, which is promoted by fiber detachment and by fissured surfaces with micro cracking. And we had a significant decline in density and also impact strength and MOR as the mechanical resistance values went down. Retarding factors we observed was a lower fiber content, which obviously lead to a lower degradation. A stiffer polymer matrix given by PVC also led to lower impacts from natural weathering and higher stability. And the co-extruded top layer is obviously an effective measure to retard the natural aging behavior of WPC in outdoor application. This is an overview about the references. And with this last slide, I would like to thank you for your attention. And if you are interested in further study results conducted by Composite, Polymer and Policy Analytics, Compolytics, you can visit the website compolytics.de. Thank you very much.